use the formula. You never use this formula. Don't worry about the formula. You can forget. Now go to 4. Go to 4.
3.
The area under the normal curve, the normal density curve. The total area is what? Of course, any continuous random variable, the area under the density curve is what? Because it represents the total probability. What is the rust? Now, the center, because it's symmetric, the center is mu. The center is mu. Now suppose this distance is sigma, so this is mu minus 1 sigma, and the sigma, the standard deviation is this much. So this point is mu plus sigma. Now look at what.
Excuse me. Can you please write it on me?
What?
Can you please write it on me? Yes,
Okay, let me make it great.
thank you.
You do not need copy, just listen. Just listen.
Then how are you going to like practice?
Normal distribution is symmetric Bell shape. Because it's symmetric, the center point is mean value. Mean value. The total area under the curve is 1. This is true for whatever continuous random variable. This is just one useful model of one of those continuous random variables. This one is very useful, so we pay special attention to study. For whatever continuous random variable, it's always true the total area is 1. Now let's look at one. If this distribution is symmetric, question number 1. How much area is here? How much area is on this side? If it's symmetric, this should be half, 50%, and the other should be half, 15%, right? If it's symmetric, because the total area is 1, correct? Now let's go on. Suppose this point is mu. Then, because the sigma is given, then this is mu minus 1 sigma. Here, this measurement is 1 sigma. This is mu plus 1 sigma. Question. How much area is between one standard deviation from the center?
68%.
The answer is about 68%. Do you remember we learned that empirical rule before, right? Empirical rule is from here. Now, do you remember another statement of empirical rule? If you go up, this is the sigma. So this is the mu minus twice standard deviation. This is the mu plus twice standard deviation. So how much area is within 2 standard deviations from the center? Do you remember? About 95%, right? About 95%, right? The probability or the population, how many percent of the population is within 2 standard deviations from the center? The empirical rule says roughly 95%. Oh, it's from here again. It's from here again. Now, go to 3. Today, that's the center of our class today. 3. Go to 3. Let's learn one of those normal distribution where the mean value is 0, the standard deviation is 1. If the mean value is 0, the standard deviation is 1. Remember, the mean value could be whatever. The standard deviation could be whatever positive number. If the mean value is 0, standard deviation is 1, this normal is called a Z. Standard, it is called a standard normal. Today, let's concentrate on standard normal. How do you use this table to work a standard normal? Once you understand, then you can work whatever normal. And the normal is a very useful mathematical model for us to study many real-life populations. Why? Because many real-life populations, they roughly follow bell-shaped distribution. So this is one appropriate model for us to study real-life populations. To understand this, you have to understand the standard, because this is the when you study this, you understand the basic idea. Then based on this, you can understand any kind of normal distribution. When this is whatever number, when this is whatever positive. So let's study this first. Remember, we use a capital letter Z to represent standard normal distribution. For standard normal distribution, the mean value, the mu is given to be 0. Sigma, the standard deviation, is given to be 1. So first, how do we study this? We use table E. Now, you have to have table E. If you have textbook, go to the back of your textbook. Go to the back of textbook, find table E. If you do not have textbook, I told you last time, everybody, you have to make a Xerox copy of table E. If you use the serial picture, take a photograph picture, I don't think it's convenient. Why? Because if you want to see the entire table, the picture is too small. If you want to enlarge it, you only see a part of it. So it's very inconvenient for you to use a picture. If some of you do not have Xerox copy, you have to use a picture. But I still strongly suggest that you have to use a Xerox copy. For the picture, you will quickly feel the inconvenience. Okay, now go to your book at the back, find table E. Find table E. Have you found the table E? You can move your chair. You share the table with a neighbor. If you do not have textbook. Or today, temporarily use the photo picture. But again, it's very inconvenient. You will see that. Are you ready? Table E. Let's understand table E. Today we concentrate on table E. How do you make use of table E? So everybody, get ready. Table E. Okay. Now, let's understand how do you use table E to work a standard normal. Everybody, if you do not have the textbook, can you please share the table E with a student next to you? Everybody, I have to ask you to have table E available. Okay, now look at the table E. First, you understand table E, then let's work on many exercises using it.
Be that the compound, because on the memory is easy to learn this thing. but I'm on YouTube. Somebody can take you to YouTube. You just take the statistic. Or even you can even download this in your phone. Yeah, I'm going to see it. I'm mentioning them.
Quick, please get ready your table E. So today in class, the most important thing is to understand the structure of table E and how do you use it. Okay. Table E is called a standard normal. Standard normal notation is Z. Z is a probability distribution called a normal distribution. Mean value 0, standard deviation 1. Okay, repeat. Z represents what? Standard normal. What is called a standard normal? Bell-shaped distribution, symmetric at the center. Center is the mean value is 0. Standard deviation is 1. The mean value is 0. The standard deviation is 1. Okay, this is for the standard normal. The graph looks like that. The center is 0. Mean value. It's a symmetric. It's a symmetric. So you have half, 50% area on this side, 50% area on this side. Now everybody understand the table. Look at the table E. The left column. Look at the table E. The left column, the top row represents Z-score. What does Z-score mean? Z-score means those points on horizontal axis. This axis, every point on this axis is one Z-score. The positive Z-scores are on this side. The negative Z-scores are on this side. The center is 0. Now suppose you have a point here. 1.3. Okay, listen. In the table, all the Z-scores, we carry 2 decimal places. All the Z-scores, we round off to 2 decimal places. Now suppose you have a point. It's a positive Z-score. 1.34. How do you find this Z-score in the table? First, you go to left column. Find 1.3, the first digit. 3. How about the second digit? 0.04, it is on top. Okay, look at your table. Did you find the left column 1.3? Yes. Did you find the top 0.4 from 0.00, 0.01, 0.02? Did you see that? Yeah. Now, so if you want to find a Z-score, which is a point on the axis, this is the first decimal place, this is the second decimal place. Once you find the Z-score, what is this? Okay, what is this? This is, okay, let's calculate. This is the left-hand side area, All the numbers in the body of the table are left-hand side area. Okay, repeat. Please understand table E. It contains 2 kinds of numbers. One kind of number is Z-score. Where do you find Z-score? Left column, top row. Second kind of numbers are all the numbers in the body of the table. What are they? They are the left-hand side area. Left, only left area, If you want to know right area, how do you do that? We say that later. So remember the table itself only gives you left area. Repeat, table E contains two kinds of numbers. One kind of number is z-score. Where do you find them? Left column, top row. What are these scores? Those points on the z-axis. Another kind of numbers in table E are here. What are they? They are the left-hand side area. Now look at the examples and work exercises. Question. Z-score 1.34. How much is the left area? Okay, listen. How much is the left area? Where do you find it? This. Okay, how much? Tell me. 0.1. And 90. Or the left area round off to 4 decimal places. These are approximations. Everyone is approximation, but round off to 4 decimal places. Repeat, please remember. In table E, there are two kinds of numbers. One kind of numbers are the z-scores, which are the points on z-axis. Where do you find them? Left column plus top row. Every z-score carries 2 decimal places. The first decimal place is in left column. The second decimal place is in top row. The second kind of numbers in table E are the left areas. All the numbers in the body of the table represents one left area. Those left areas round off to 4 decimal places. Now, for the first example, look at what. What is the probability for this random variable takes a value smaller than 1.32. Okay, look at what. Do not copy. The most important thing is to understand. If you say z takes a value smaller than 1.32, where are the possible values? They are here, right? Right?
Yes.
They are on the left-hand side, right?
Yes.
Then the probability equals that left area of 1.34. Not 1.34. So. Now, how much? This much. So about 91% chance the random variable z takes a value smaller than 1.34. Okay. Question, meaning, answer. Where do you find answer? Use the table. Okay, this is the first question. Now let's work exercises to understand. Go to your lecture notes. Don't worry about lecture notes. Just look at what. Take out a sheet of scratch paper. Let's work. Okay, listen carefully. How do you understand the question? The question is, what is the chance for the random variable z, or the standard normal, it will take a value smaller than negative 0.3? And this number is a point, is a z-score, When you use table E, every z-score carry 2 decimal places. If the question contains only 1 decimal place, you can purposely add 1. Yeah. 0.3, 0.30, same, right? 0.3 equals 0.30. You know that, right?
Yes. Yeah.
Okay, so if the z-score does not have 2 decimal places, you purposely add 0 to make 2 decimal places. Because in the table, every z-score contains 2 decimal places. First, you understand. Now, how do you find it out? You find, okay, question. If z is smaller than negative 0.3, where are the possible z values? Which side of this point?
Left.
Left hand side. So it equals the left area. The left area to this point. Now how do you find it? Okay, go to your table. Find left column, you find negative 0.3. The top column you find what? 0.00. Yes, 0.00. So what is this?
0.3821.
Let me erase the previous question. Let's look at the current question. What is the center of standard normal distribution? Mean value 0. Where is the negative 0.3? It is on which side?
Left.
The left hand side. 0.3 we purposely add a 0 because all the z-scores in the table contain 2 decimal places, so we purposely make it 2 decimal places. Now what's the answer? 0.3 821. Yes? Okay, so the answer is about 38% chance this z will take a value smaller than negative 0.3. This is the second example. Okay, another very important question. Another very important question. Before you use the table, can you answer my question? Listen. Before you use the table, can you answer my important question? The answer to this question is probability. Of course, it's a positive number. It is between 0 and 1, of course, right? Okay, listen to me. Can you follow me? Yes. Because the question is probability. So the answer must be a number between 0 and 1, right? Yes? Okay, my question is, do you know whether this number is smaller than 0.5 or greater than 0.5? Smaller than half or greater than half? Now look at the graph. This is the center. Okay, it's a very useful concept. This is the center. What is the total area under the curve? 1, always. So, because it's a symmetric, so 50%, half is here, half is there, right? Yes. Left hand side area is half, the right hand side area is half, right? Now, for our question, the answer is the left hand side area to this point. Now, this is less than half, greater than half. Must be less than half. Before you go to table to find the answer, you already know the answer must be less than half, right? Before you find the answer, you should know the answer must be less than half. Do you understand why? No.
The negative?
Do you understand why? Before you see the answer, you should know the answer is less than half or more than half. Look at the graph. What's the answer? The answer equals the area to the left hand side of this point. The area is more than half or less than half. Must be less than half, right? The actual answer is this. The actual answer is this. So it must be less than half, and actually it's 3/8, right? Now look at another example. Then let's take a break. Third example. What is the question? The question is, what is the chance? What is the probability the random variable z takes a value smaller than positive 0.94? Okay, you found already, but I have several basic questions. Before you answer the question, there are several basic and important questions. Question number 1. Every probability is corresponding to one area. This is the right side area or left side area to this point. This probability equals which side area? The area on which side of this point?
It's on the right.
Left side, right hand side.
Right.
Left hand side. Why do you know that? Smaller than
Oh,
if
less
z
than.
is smaller than this point, then all the possible values of z is on the left hand side. You know that from algebra, right?
Yeah.
Everybody learned the number line before, right? Smaller side, smaller the value is on left hand side, the greater value is on right hand side. Yes?
Okay.
So, question number 1. This probability equals the left area. Okay, very important. You have to decide the left and right. Left area. Left area of this point. Now, do you remember I said already several times, all the numbers in the body of the table, they represent what? They represent the left area, right? Do you remember that?
Yes.
So if you need the left area, you directly go to the table to find the answer, right? Now, you go to the table. How do you find this value? From left column, from top row. Can you find that? Can you find that? 5 positive 0.9. 5 positive 0.04, right?
0.826.
And what's the left area to this? Oh, okay. No. Stop. Before you use table, I have the second question. First question is left area or right area? First question. You understand this should be left area, right?
Yes.
If this is greater, then right area, correct?
Yes.
Okay. Second question. Do you think the left area, do you think the answer is greater than half or less than half?
It's greater than half.
Supposed to be less than that.
Okay, some of you understood the idea, some of you still didn't. Now go to table, Where is 0.9 for the z? On this side, right? If on this side, the left area should be more than half, less than half.
More than that.
More than half, right? You see that this is half. The center is here, so this is half. This should be more than half, right?
Yes.
Second best question is first. Okay. Repeat. First question is this probability equals which side area? Left area or right area? Left. Left area depends on this symbol, right? Second question is that left area or right area is more than half, is less than half. That depends on the graph, right? More than half. Now you go to find the answer, exact answer. What's that? How much? 0.8. Say 8, 2,
6, 4.
Yes. it's about 83% chance the random variable will take a value under 0.94. Can you understand that?
Yes.
Now try one by yourself.
Good. Very easy.
Okay, now please, can you please? How do I do wait. It's not this table, not this table. This one. This is positive, this is negative. Oh, how do you, where do those
given. The
numbers come
numbers
from?
is given.
By integral calculation.
Is given.
Don't worry about where they come
Engineer
from.
Samson.
They are from the integral calculation. Okay, last one before break. Question. Why is okay, everybody, the question is, first, you have to completely understand how to use the table, otherwise you cannot go on.
Okay.
Second, a student says, how do you understand this?
Greater than half.
Okay. What is our question? The question is 0.94. The first digit of the z-score is you found it from left column. The second you find from the top. So this one plus this one together make this number. Now everybody, let's work on whatever we can break. Question number one. Before you use the table to answer the question, before you use the table to find the answer, I have two basic questions. What is my first basic question? Left area, right area. Is this probability the left area or the right area of this point?
Left area.
Yes. You have to have a clear idea. Because the probability equals area, so you have to know whether it's the left area or right area. How do you know it's left area?
Because of the sign.
Do you understand that?
Yes.
Second, is this area greater than half, less than half? Greater than half. How do you know that from the graph?
Yeah, from the graph.
From the graph. 1.64 is here, right? And this side, right? You want to find the left area, it must be more than half. Why? Because this is half, right? This is more than half, of course, right? Now you give me the exact answer. 0.949. Okay, is that correct? Okay, now let's take a break of 10 minutes. After break, we go on with table E. Okay.